Moving into a different aspect of functions here, you can see these are going to be the notes. It says graphing linear functions. And linear just means if you look at the first 4 letters of the word, they will form a line. And we'll get into more theory later, but for this assignment, you're just going to fill out this table and then graph it. So I'll show you what's happening here. Here's the equation. It says y equals 2x minus 1. That means 2 times x minus 1. So these are the x numbers, and they are the input. We will get an output once we put the x numbers in. So for instance, instead of 2 times x minus 1, I'm going to do 2 times 5 minus 1, then 2 times 2 minus 1, then 2 times 0 minus 1. So I set it up just to save time. I use parentheses for the multiplication, so I'm just going to put the 5 there. And I just do the math. You can use a calculator. 2 times 5 is 10, minus 1 is 9. Now your assignment does not have this column over here. That's just to write the ordered pair. You don't have to, but the ordered pair is 5, 9. So when x is 5, y is 9. And on we go. You just put the input number in for x. 2 times 2 is 4, minus 1 is 3. And again, 0. 0 is a good number to work with, everybody. 2 times 0 is 0, and 0 minus 1 is negative 1. So again, don't worry about this column. You don't even have it on the assignment. So time to graph. I'm going to slide this up. The first ordered pair I'm going to graph is 5, 9. So I start at 0. I go over to 5. I hold there. I look. The y number is 9. So I have to go all the way up here to 9. That is 5, 9. Graph 2, 3. I'm just graphing this next ordered pair right here. 2, 3. I start at 0. X is positive 2. Y is positive 3. I'm right there. And the last ordered pair, 0, negative 1. If x is 0, I don't move left or right. But y number says drop down 1. Okay. They should line up, the points that you have. They might be distanced differently. Like that's a smaller distance than that. That's because these numbers have different distances between them. See, 5 and 2 are 3 apart. 2 and 0 are just 2 apart. That doesn't matter. As long as they line up. When you draw a line, now look how I went through the points. And I put arrows on these lines. You have to do that. Okay, this is showing the work. And this is your final answer, basically. Well, there's 2 answers. There's the table and the graph. Okay, some questions I always get. Why did you use those numbers? Can I use other numbers? The answer is yes. You can use any numbers. You could pick 712 for x. But your graph is going to have to fit 712 for x. So we normally pick small numbers that fit on the graph. For example, if I pick 4 for x, I would get that point right there. It would still be on the line. Okay, now I don't have to do all these examples or this video would be 20 minutes long. But I'll do 2 more. One that has a negative number. So, for instance, this one, negative 4 times x. Well, x is negative 2. So I'm showing my work. I'm going to do negative 4 times negative 2. Then I add 1. Negative 4 times negative 2 is 8. 8 plus 1 is 9. So I go graph the ordered pair, negative 2, 9. When x is negative 2, y is positive 9. I'm up here. And 0, again, 0 is a good number. It's in all of your homework problems. Negative 4 times 0 is just 0, and 0 plus 1 is 1. And 0, 1 is right there. And negative 4 times positive 1. See, I'm just taking these numbers and putting them in for x. Negative 4 times 1 is negative 4 plus 1, negative 3. If you're not real confident with negative numbers, everyone, use a calculator. Okay, so the ordered pair, 1, negative 3, 1, negative 3. Don't connect the dots if they don't line up. You made a mistake. Your mistake's either in the table or you're graphing. Don't draw triangles and boomerangs and lightning bolts and all the craziness that I get, okay? Only if they line up. Last one I'll do, because you have one that has just a negative x. You'll have a positive x, but that one's pretty friendly when you put this number in. 5 minus 5, 0 minus 5, negative 2 minus 5. You have one that looks like that. I'm going to do this one because you also have one that looks like this, negative x. That really means negative 1 times x. But the shortcut is, if I'm going to replace x, oh, that should be a negative x right there. Negative x with negative 6, it's just going to be positive 6. So it's the opposite. Okay, it's a double negative. Well, 0 cannot be negative. You just ignore the negative sign. But this one, if I'm putting 4 in for x, and there's that negative in front of it, 4 only replaces the x, not the negative. So it would look like that. Okay, so it's really just the opposite, but if you'd rather do negative 1 times the number, you'll get that anyway. Everyone does their own thing. But 6 plus 2 is 8, 0 plus 2 is 2, and negative 4 plus 2 is negative 2, and I graph my ordered pairs. Negative 6, 8. See, I'm over here at negative 6. Go up to 8. 0, 2. When x is 0, everyone, you are on the y-axis. Notice, always. Okay, when x is 0, you're on the y-axis. Okay, if y is 0, which I don't think happens in our assignment, it might, that didn't happen on the examples, you're going to be on the x-axis. Last ordered pair is 4, negative 2, positive 4 for x, negative 2 for y. It looks like they line up through the points with arrows. Okay? They're lines. They're not line segments. They go on forever. I could pick numbers forever. Okay, so that's essentially our task. There's only 4 of these. This is a one-sided assignment. I made it look very similar. On purpose, of course. So just show the work. Notice there's the positive x, number 3, and there's one like I just showed you. No, it's not on here. I'd have to, don't worry, this is the assignment. I'll fill it in. Okay, if you have any questions, sorry about all the paper moving, let me know.